Okay, so I'm ready to show you how to algebraically solve the equation cosine of 2 theta is equal to -1/2. We saw that this 2 changes the period from 2 pi to pi, so it changes the number of solutions that we're going to expect to see on this interval. The first thing I want to do is to rewrite this in an equivalent form where we're saying what is the angle whose cosine is -1/2. And I'm going to answer that on the interval from 0 to 2 pi, and then I'm going to use this idea that my new period is pi to come up with the actual solutions to the equation. There are two angles whose cosine is -1/2 on our unit circle. Here at 2 pi over 3 and at 4 pi over 3. So I'm going to let those two angles be equal to 2 theta. So when I solve this first one, I find that theta is equal to pi over 3. And when I solve the second one, I find that theta is equal to, 2 pi over 3. We said that our new period is pi, so we had two solutions originally on 0 to 2 pi. So if we want all the solutions on the interval from 0 to 2 pi, we saw from the graphs that we would expect two more solutions. And they're going to be, because of the period being pi units beyond these two solutions. So pi more than pi over 3 is 4 pi over 3, and pi more than 2 pi over 3 is 5 pi over 3. So as we expected, we find that we have four solutions: pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Our second example that we explored was the tangent of theta over 2 is equal to √3. Just like we did before, I'm going to rewrite this thinking about what are the angles whose tangents are √3. And I'm going to set that equal to theta over 2. We know for the tangent, the period is pi, but now I'm going to divide by 1/2. So the period is extended to 2 pi, because we would have found two solutions on 2 pi. If we've not had this transformation, we'll now only find one solution on 2 pi. So where is the tangent √3? I'm going to think about that coming from √3 over 2 divided by 1/2, this being my numerator being my sine, and my denominator being my cosine. So where do I have a sine of √3 over 2 and a cosine of 1/2? That theta over that angle would be at pi over 3. So my theta over 2 is equal to pi over 3. Theta now is equal to 2 pi over 3, and I only have one solution.